unexpected physical phenomena for further study. Modern observatories observe the sky continuously, and data accumulates remorselessly in the digital archives. The growth rate is impressive, and many hundreds of terabytes, corresponding to many thousands of billions of pixels, are already available to scientists. The real sky is being digitally reconstructed in the databanks. However, reaching this digital sky will soon become a problem. The efficiency of modern instruments and detectors is doubling every 12 months, while the power of our computers doubles only every 18 months, and even worse, the capacity of the current network doubles only every 20 months or so. To illustrate the data flood that astronomers will have to face in the future, some of the telescopes planned for the next decade will deliver so many images in one night that it will take more than a month to transfer the data over the internet as we know it today. This is not only a technological issue. Astronomers are not yet trained to deal with such a diverse and expansive set of data, nor is our brain equipped to analyze the millions and millions of available images simultaneously. We may have clear scientific goals, and we may have the necessary data, but we have not yet developed the tools and methods to extract the relevant data from amongst the flood of images available. A new way of thinking, a new frame of mind, a new approach is needed. The digital sky has the potential to become a vital tool with novel and fascinating capabilities that are essential for astronomers to make progress in the understanding of the cosmos. To solve the technological and operational issues, a new, powerful observing tool is needed to enable astronomers to extract data from the digital sky efficiently. The Astrophysical Virtual Observatory, or AVO. Astronomers can elicit information about rare objects which are potentially crucial for resolving fundamental questions about the universe by searching for them in the digital sky. A search of the real sky would be too costly and would take far too long. For example, astronomers will be able to retrieve the elusive traces of the passage of minor asteroids to reconstruct their orbit, size, and eventual fate by pasting together observations taken at different times. Or, when an old star in a distant galaxy explodes in an extremely energetic firework display called a supernova, astronomers will be able to go back and examine previous images of the same galaxy, taken before the event and readily available in the digital sky. They will be able to pinpoint the star shortly before it exploded, thereby adding invaluable data to the theoretical study of the evolution of stars. Fortunately, astronomers are not alone in their battle against the data flood. Many areas of research are facing similar problems. A solution has been envisaged, and major scientific and technological organizations, including the European Space Agency, are experimenting with it. The solution is called GRID. GRID is a new concept for using the World Wide Web. It will improve the efficiency of information exchange across the network, but more importantly, it will offer distributed supercomputing capabilities to its users. Using GRID technology and the Astrophysical Virtual Observatory, astronomers will no longer need to transfer large quantities of data over the network. The data will remain at their own home sites, in the different digital archives at the data centers. The GRID supercomputing capability at each data center will carry out the data analysis and relay the results back to the astronomer. For example, astronomers can ask the AVO to find out how many galaxies are likely to host a massive black hole at their centers by simply specifying the characteristic features of a typical candidate object. AVO, thanks to the GRID technology, will launch several browsing and analysis procedures across the Internet that will operate in parallel on different data sets located at different centers. Only the result of the analysis, here a list of possible candidate black holes, will be delivered to the astronomer, who can then refine the search by sending out further queries across the net. We are at the beginning of a new era, where data collected by a multitude of sophisticated telescopes can be used globally and repeatedly to achieve substantial progress in our quest for knowledge. The European Space Agency, in collaboration with its international and national partners and with the European Commission, is fully committed to support the deployment of grid technology and the development of grid applications such as the Astrophysical Virtual Observatory. ESA believes that these initiatives contribute effectively to the building of the European research area, open to the entire world and enabling steady scientific progress.